Hi, this is team24. My name is Ruihao Zhou. I am here to serve as an introducer to our first compiler project. Okay, now let's begin. This is the outline of our project. I was taking part of the grammar lure and the lecture analyzer, and Hongfei, she was taking part of the compiler and the intermediate code. Zach Wang was taking part of the runtime environment and the interpreter. So our project name is L0. As you see, 0 is the first natural number. We regard L0 as a good start of our learning in compiling techniques. So we have two primitive type. One is Boolean and the other is int. As for the operations, of course, we have the larger, less, plus, minus, multiply, divide, and not equal, such as some basic operations. As for statements, we don't have the for loops. So here we have the assigned statements, if-else statements, and while statements for our to realize the basic function of any language. Here, this is our grammar lure. We just follow the assignment 2. I read my grammar lure with Hongfei. So, as the compiler phase, we generally input our source code, then we generate the token list. Then through the parsing, we got our intermediate code. So here it is the lecture analyzers. We use the symbol table as our data structures to realize the functions. It has two phases. One is to read the source code and separate the character into tokens. The second phase is to store the tokens and restore the corresponding type into our symbol table.
Hi, my name is Hongfei Ju, and I will demonstrate our parser and intermediate code generator. For our parser, it has two major functions. First, check the syntax. Second, generate the parsing tree. After getting the token list from a lecture, our parser will read the tokens one by one and check the order of the tokens to see whether it matches our syntax rule. For example, for our declaration statement, and our parser will check whether the first token is var or not, and whether it's followed by an identifier, and whether it's end with a semicolon. If the order of tokens match this structure, and our parser will continue to check the next statement, otherwise it will show an error message. For the second function, generating the parsing tree, actually generating the parsing tree and checking the syntax, they are almost done at the same time. After the checking process succeeds, the parser will extract the key information and keep it in an abstract syntax tree. And here is the data structure that we use to generate the parsing tree. There is a string to store the key information of the node, and the node has at most 3 children. Let's use assignment statement as an example. After parser check an identifier successfully, it will extract the name of the variables and keep it in the parsing tree as one child. And after the parser check the low expression successfully, it will extract a number and keep it in the parsing tree as another child. That's the way how it works. After getting the parsing tree, we can go to the next step, generating the intermediate code. Here is our intermediate code generator. Our intermediate code generator will traverse the parsing tree in a pre-order. The parent node first, and the children second. Based on the structure of the subtrees and the content of the nodes, our intermediate code generator will generate the corresponding intermediate code and keep it in a linked list, and finally write it in a text file. Here, we still use the assignment statement as an example. For assignment node, it should have two children. First, it should be an identifier subtree, and second, it should be an expression subtree. The intermediate code will try to get the variable name from the identifier subtree and get a value from the expression subtree, and keep it in the linked list. It will add the variable name first, an assignment operator second, followed by the value, and all this part will be used as one instructor in the intermediate code. And here is the way how it works. Now, I will show you how to use our compiler, and here is some samples that we will use to demonstrate our compiler. And here is the content of these samples. As you can see, these samples cover all the features of our programming language, including the declaration statement, the assignment statement, if statement, while statement, print statement, the arithmetic expression, the Boolean expression. Now, let's compile them. And here is the jar file that we created based on our codes. You can download it from our GitHub. It seems works for the first sample. And as you can see, it showed all the information in every step, including the token list, the syntax checking information, and the intermediate code. At the same time, it generated a test file with the intermediate code inside. It can be used for the interpreter. And now, let's compile others. Everything works for all samples. Now, let's do something different. Based on our grammar, for the declaration statement, the var should be followed by an identifier. Now, let's delete it. Let's see what will happen. Some error message. The identifier expected. It means that at somewhere you should add the identifier. And that's how our compiler works.
Hi, this is Zachary. I'm gonna talk about the runtime environment with the examples. Okay, let's talk about the implementation of interpreter, or you can say the implementation of runtime environment. So first we need to receive the input file here, and then after that I scan off the intermediate code and then put them into the string array. And then I also declare a hash map here so we can record the memory and then the value with memory. After that, I need to analyze the type of the intermediate code. So we have 6 types here. Okay, let's start from the type number 1. Type number 1 is the intermediate code with this sign. And then type number 2 is the assignment, like the M3 get M5, or something like the M7 gets a value like 3. And then the type 3 is the intermediate code with the keywords like the if not and while. And type 4 is the intermediate code with keyword go to. Type number 5 is the simple labels without doing anything. And then type 6 is the print. And then in our programming language, it's the print with new line. So after we know what type of the intermediate code line. We put a type into switch and then deal with them depends on the type of the intermediate code. And then in the end, we can know the result. And then usually we just print the result in our programming language. Okay, this part is interpreter with examples. So let's compare the interpreter first. No problem at all. Then let's run the first example. So press enter. And then we have 120. This is the 5 factorial. So after interpreter receive this intermediate code, we have 120. And the symbol do is here, and let's see what happened. We can see so we have 86. So here we can see that if this variable is larger than factor 2, we can have a factor 1. And then because 86 is larger than 10, we should have 86 like it says, like the interpreters say. And then let's try the example number 3. So sample 3 here. We have 7. Simple 3 is the simple math calculation. So 1 plus 6 minus 0. So we should have number 7, like you can see. And then this is the simple 3 intermediate code. And then let's try the simple 4. So let's run the simple 4 and then press enter. We can see 55 here. And as you can see, this program can add up 1 to 10. So we can have the result 55 like you can see before. And then here is the intermediate code for simple 4. And then let's try simple 5. Simple 5 is the if else with print, like you can see. So it print the 1 from the very first because number is less than 10 from the very first, and then it prints 6 ones and then print the 5 zeros. At the end, it print the number and it's 11 because when number larger than 10, it will go out of from the while loop, and then we can have 11 like you can see here. And then here is the intermediate code for simple 5.